Good morning everyone, my name is Sahana and today I am presenting my assignment 1 for Automata Theory and Computation. The title of my assignment is Lexical Analyzer and Parser for MiniATC language. These assignments demonstrate the practical application of automata theory concepts such as finite automata, lexical analysis and parsing in compiler design. Let's see, introduction. Automata theory is an important area of computer science that deals with mathematical model of computations. It is widely used in compiler constructions, syntax checking, and programming language processing systems. A lexical analyzer is the first phase of compiler which converts source code into tokens. A parser checks whether the sequence of tokens follows grammar rule correctly. In this assignment, I implemented a lexical analyzer and parser for a simple programming language called MiniATC. An example begin int x is equals to 10, print x n. This is a simple mini ATC program where variables are declared, assigned values and printed. And problem statement, the main objective of this assignment is to implement identifier recognition using finite automata, lexical analyzer for token generation, parser using context-free grammar for syntax validation. The system should correctly identify tokens such as keywords, identifiers, numbers, operators, delimiters. It should also verify whether the mini ATC program follows grammar rules correctly and display syntax error if any rule is violated. And mini ATC language specification. Mini ATC language specification is designed for understanding compiler concepts. Every program starts with the keyword begin and end with the keyword end. Uh, the language supports three types of statements: declaration statements, assignment statements, and print statements. For example, x is equals to 10, print x. Declaration statements are used to declare variables. Assignment statements are used to assign values values or expressions to variables. Print statements are used to display variables values. And lexical elements. The lexical analyzer identifies different types of lexical elements or tokens present in the program. Keywords are reserved, for example, you will say in table, keywords are reserved words such as begin, end, int and print. Identifiers are variables names such as x and total one. Number represent integer constants. Operator are symbol like plus, minus, multiplication, division and assignment operators. Delimiters are symbols such as semicolon and bracket used to separate statements and expressions. These tokens are the basic building blocks of mini ATC language. And DFA for identifier recognition, this diagram represents the deterministic finite automata used for identifier recognition. Q0 is the start state. If the first character is a letter, the automata moves to Q1, which is the accepting state. In Q1, additional letters or digits are accepted and the automata remains in Q1. If any valid symbol is encountered, the automata moves to dead state QD. Therefore, only valid identifiers are accepted while invalid identifiers are rejected. Next, we will see context-free grammar. Context-free grammar or CFG is used for syntax analysis. CFG defines the structure and rules of the programming language. Uh, we will see here. These rules specifies that every mini ATC program must begin and end with end. Other grammar rules define declaration statements, assignment statements, and print statements, and arithmetic expressions. The parser checks the sequence of tokens according to the grammar rules. If all rules are satisfied, the program is considered syntactically correct. And algorithm, lexical analyzer or algorithm works as follows. Read the first read the input program and scan characters one by one and group characters into tokens. Identify whether keywords, identifiers, operators, numbers, and delimiters, and display generated tokens. And also parser algorithm works as follows. Read tokens from the lexical analyzer, apply CFG rules, verify statements and expressions. If grammar rules are satisfied, display valid program. Otherwise, display syntax error. And lexical analyzer code. This slide shows the implementation of the lexical analyzer using Python programming language. Uh, Keywords, operators, and delimiters are defined initially. The program scans each character and checks whether the token is a keyword, identifier, or number. If the token matches a keyword, if it is stored as a keyword token. Numerical values are stored as a number tokens. Variable names are stored as identifier tokens. Thus, the lexical analyzer converts the source program into tokens. And let's see implementation of parser. This slide shows a snippet of the parser implementation written in Python. The program function checks the overall structure of the MiniATC program. First, it checks whether the program starts with the keyword begin. Then it calls the stmt list function, validate all statements present in the program. Finally, it checks whether the program ends with the keyword end. The parser uses recursive function based on context-free grammar rules. Each grammar rules is implemented as separate functions. The parser verifies whether the statements and expressions follow the grammar defined for many ATC language. If all tokens follow the grammar correctly, the parser accepts the program as valid. If any grammar is validated, the parser displays syntax error. Let's see output. Here a valid MiniATC program is executed. The lexical analyzer correctly identifies tokens and the parser verifies grammar rules successfully and shows the output valid program. In invalid program, in output, the grammar rules are violated. So therefore, the parser detects the error and displays syntax error. And we can see both, which is one is this is the code of lecture.py. If we run this, we got this as the output, which is token generated, keyword begin, keyword end, and in last keyword end. And also this is the parser.py. This is all the code. If we run this, we can say valid program. If we change any tokens, we got syntax error. And lastly, conclusion. Thus, the lexical analyzer and parser for MiniATC language were successfully implemented using automata theory and context-free grammar concepts. These assignments helped me understood finite automata, token generation, syntax analysis, and compiler construction practically. The project also demonstrated how lexical analyzer and parser are used in real-world programming language processing systems. And last, thank you all.